So this question here is based on an ellipse at the top here. So A, B, C, D and E all the way back to A is based on an ellipse. A, F, E is a parabola, and as you can see we're only given some construction knowledge. So if we look at the question, it says the curve A, B, C, D, E is based on an ellipse having a minor axis of 60. So we know that the distance from here to here is 30. We're being told that our minor axis is 60, so we're going to put 30 on our compass. Now we are not given the major axis. Okay, so we're going to start off with that. So I'm going to start off, I'll get my compass, put 30 onto my compass. And when I get my 30, I'm going to draw it. Lovely. Draw in your minor axis and draw in the line that your major axis will lie on. So we don't have the major axis, but I know my major axis will lie in that line. I'm going to draw in my minor axis. Now, by drawing in my minor axis, that's after giving me 2 points on my curve. So I now have 2 points on my curve. Okay, so we're going to go back to the question, just see what else the question has given us. Now, when we look at the question, I have a point A and a point E that's on the curve. I know that E comes down 45 mil, and I'm told the distance between A and E is 140. So if I measure over 70 and down 45, so on this point here, I'm going to come down 45. And from that point, I'm going to draw a horizontal line. On that then, I'm going to measure 70 in both directions. And that gives me point A and E. Now, I know for a fact that A and E are both points on my curve. So there's A and there's E. Now, we're just going to do a little bit of construction. In a normal question, I'd have a major circle. I'd have a major axis. I'd have a minor circle, and I'd have a minor axis. Now, I have a point here that's in the bottom left, so I'm going to work with the bottom left. I'm going to draw a random line. Where my random line cuts my major circle, I go parallel to my minor axis. Where it cuts my minor circle, I go parallel to my major axis. And that gives me a point on my ellipse. Now I'm going to call it A for argument's sake. So I can see I have a point A here, and I have a point A in my actual question. Point A goes horizontal until it hits the minor circle. I have that. It goes horizontal here and it hits my minor circle here. This point connects to the center point and is extended on. And from point A, we're going to draw a line parallel to my minor. And where that cuts, that point is this here, which is a point on my major circle. Now, it's very important that we understand this. So, from A, there's a line drawn parallel to the minor axis. From A, there is also a line drawn parallel to my major axis. Where that line cuts my minor circle, there is a diagonal line drawn from the center point. Please draw your sketch on your page. It is very important. It will help you massively with your construction. That's after giving us a point in my major circle. So I put the point of my compass at the center, and I'm going to draw in my major circle. And when you have your major circle drawn in, that's after giving us another 2 points on my ellipse. Now, as we know, that's still not enough points to draw your actual curve. So I need to get the top half of my curve. So I'm going to divide it up using my 60-30. You do not have to divide it using 60-30. However, using 60-30 is the easiest way of doing it. When it hits your major, parallel to your minor. When it hits your minor, go parallel to your major. Because we divide into 60-30, we can find those points at the same time. It's a little handy trick. And once we have our dots, we're going to join them together. You'll notice I haven't found the bottom of the ellipse. Okay, and we can darken in. So that's after giving me my ellipse shape. Now, always, please, even when you're not asked for it, always find the focal points. Half my major swung from the top or the bottom of my minor axis, and that gives me F1 and F2. Very important that we always find them, because they're a very important part of an ellipse. So that's after giving us that part of our ellipse there now. Okay, so next thing, I'm going to go back to my question. And when we look at our question, next thing I can get is two eyes. So I'm told that they're on the major axis, their diameter 22, which is going to be radius 11, and they're 60 mil apart, which is going to give me 30 on both sides. And that's actually my minor axis. So I know those are the 2 points. Now, whenever we get a center point, very important that we draw it in. I'm going to get my compass now, and on my compass I'm going to put a distance of 11 millimeters. The smaller the circle is, the harder it can be to construct. It doesn't help lead. Darken them in later. Okay, so the next thing I need to do. So next thing we need to draw when we look at our question is a parabola. Now I'm told a point F is a point on the vertex. That's the vertex of the parabola. And I'm told that it lies on this circle. However, we are not told the radius of the circle. But if we look closely, we can see that the circle touches point A, C, and E. So I know they're points in my circle. So what I'm going to do is I'm going to join point C to point A. And I'm just going to put this in colour just to show you. Now what we have is we've joined 2 points of a circle together. These look parallel, don't worry about that, okay? So if I have a circle and I draw a line, that line is called a chord, C-H-O-R-D. Now, so that's point A and that's point C. So that's a chord. There's a rule that states that if you bisect a chord, the center point of the circle must lie on it. Now, I know the center point of my circle has to lie on this center line because I'm told that. So what I need to do is I need to bisect A to C. I get my compass and I extend it roughly 3/4 of the way. Swing arc, 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 and arc. And I draw them together and I extend the line. They meet at this lovely point here. Whenever we get a center point, we always draw in the little cross. And once I have that center point, okay, I'm going to put the point of my compass here, extend to E, and because I've done it right, it should extend to my 3 points. Sorry, I'm having a little bit of trouble with that compass. Lovely. Now, the point that I need is this point here, which is point F. Point F is the vertex of my parabola. So I'm going to look here. I need to get a parabola that is going to go from E to F, and it's an upside down parabola because my vertex is down here. So what I'm going to do is I'm just going to draw the rectangle that it would lie on. Okay, so my parabola is going to go inside this rectangle. Now, you have to divide up this side. It does not matter what you divide it up into. I usually pick 4 because I find 4 is a good number. Anything below 4 generally doesn't give you enough points. So we get a random distance on our compass and we mark it off 4 times. The very last point, we join that to the point in our rectangle, and that's making a scalene triangle. Now, using sliding set squares from each other point, I draw a parallel line, and each time that's given me a scalene triangle, which is the exact same size but markedly smaller. So that's divided into 4. This point here is closest to the vertex, so that's 1, 2, and 3. From points 1, 2, and 3, we're going to draw vertical lines down, and these vertical lines are obviously parallel to the axis of my parabola. Now I need to divide up this side part here, so I'm going to go random line again. And on my random line, because I divided this into 4, I have to divide the side into 4 also. So 1, 2, 3, 4. Last point joins up here to E. Yet again, that gives me a scalene triangle. I'm going to use sliding set squares Now, this point here is obviously closest to my vertex, so that's 1, 2, and 3. These 3 points join to my vertex, which is point F in this question. And 1 hits 1, 2 hits 2, 3 hits 3. And once you have your dots, we're going to freehand them to get our curve. Lovely. Now, we need to get those points on the other side, so we're going to use axial symmetry. Obviously, if you want, you can go away and do all the construction again, but there is absolutely no need. The axis in the middle divides our shape symmetrically in two. And once we have those points, freehand. I like to draw my curve in light first, so I have a path to follow when I draw it in dark. Lovely. So that's given me that portion there of the head. Fabulous. And you can see our different constructions. Now, next, if we look at our question, finally, we have to get the mouth. Now, I'm told to, if we look at the question, I'm told that the curve JKL is based on this ellipse. So this ellipse is the exact same as this ellipse. I'm told to come up 18 and I'm told to come up 20. I am not told any distances here, so I need to find them. So I have an 18 and a 20. So down here, 18 and 20. Okay, so this point is the exact same as this point. Now this point here is 20. So what I'm going to do up here is I'm going to take this 20 and I'm going to mark it up here on the right. It doesn't have to be the right, but I've also done a lot of construction on the left, so I'm now working on the right. And I'm going to draw a vertical line. Now I'm just going to get the other bit of that ellipse there just to draw it in. Now, what I'm going to try to do is I'm going to take this part of my ellipse and I'm going to bring this down here for the mouth. I have this point here and I have this line. So, because I have that line there, and I'm just putting these in colour just to highlight them for you. If I get the distance here and mark it off, this line is the exact same as this line, and I can darken in that line because that's going to be the top of the mouth. So I've found the 3 points. Technically you could draw your ellipse, but obviously it's better to get another distance. There's a distance there of 20. Half 20 is 10. You don't have to do 10, but it's a nice number to use. So I've gone out 10. I've got a line. So down here in my view, I'm going to go 10. I'm going to draw a line, and I'm going to get the distance of that point there. And now this line is the exact same as this line. That's after giving me 5 points on my ellipse curve. Obviously, the more points you get, the more accurate it's always going to be. Now, I'm just going to do this just to show you what I'm after doing. In your exam question, you obviously would not have to do this. So we've taken this portion of our ellipse and we've placed it there. And that's our question completely finished.